You're really quiet today. I know it's 9 o'clock in the morning. I know it's on a second day, but good morning. Hey, now we're talking. Good. Are you ready for some nightmares? I mean, no, I know it's in the morning. I mean, still, but you know, it's the best time to kind of do a retrospective of all the kind of nightmares we might get, right? That's the plan. So there will be some nightmares, but there will be some nice things as well. I mean, there will be more of the nice things. There will be even unicorns and stuff. So something to look forward, right? Couple of words about myself to get started. My name is Rustam. I work and live in Norway, in Oslo, and I work for a consultancy company called Kompetas. I am quite heavily involved in Norwegian Java user group. I've been leading it for a couple of years, and now I'm doing other stuff there as well. Right now I'm leading another Java conference, Java Zone in Oslo. And I'm a Java champion as well. So, enough of talk about the other stuff. Let's talk about what we're here to listen to talk about, right? So, developer nightmares and how that thing kind of came along was that last couple of years I was working in my company as a consultant. I'm getting hired by customers to do software review. So to do some checks of systems, that existing systems, or maybe systems they're planning to build, or sometimes even when there is an acquisition happening, so some company wants to buy or invest in another company, they would hire someone like me to say, hey, this is the system, can you have a look, and can you come back with some feedback and, like, you know, see if it's worth paying that much money to that, or if it's more than enough, or if we want to do something about it, or how we want to do, you know, all those kind of questions. So lots of questions, and it's just me kind of trying to go through that kind of stuff. Well, sometimes it's not only me, but yeah. When I talk about systems, I usually talk about systems, and especially in this talk, I'll be talking about systems that are quite big. And by big, I mean like 350,000 line of code and more, so like 400,000, even more, you know, those kind of systems. Teams, like quite big teams, 20 developers, more, you know, 20 plus developers. Systems that's been around for more than 10 years, 10, 15, sometimes even 20 years. So it's like some legacy stuff, some, you know, all those kind of things. So it's a mix of all these kind of things that are the kind of usually the systems you typically end up seeing and doing reviews on. Sometimes they're younger, sometimes they're newer, so they're like been around less, but still, this is kind of just to give you an idea, right? I also worked, I mean, it's like in addition to being hired to do this kind of stuff, I also worked in the systems, again, as a consultant, as a tech lead, architect, and that kind of positions in the projects like this size. So I was working like, the last project was, I think, 450,000 lines of code, Java code, to compile all that. It actually took us quite some time. Every time you would build everything with tests and everything. So what happened was that I kind of tried to have a look at all those things I've seen and try to kind of compile a list of things, bad things that we do as developers. And some of the things, and quite a few of those things, are actually quite obvious things. And everybody would think like, well, you know, of course I know that you have to do this, and of course I know that you have to do that. But still, for some reason, for one or another reason, we don't do it sometimes, or quite often actually. And there's also, sometimes we just don't think it's necessary to do. Sometimes we're not allowed to do it from the management, like project managers or anybody else, like stakeholders who's paying for that stuff and everything. So my point here is to give you a list of things that we can make sure that we can try to work on, try to make nice, and try to continuously work on improving, right? I also might want to give you some tips, or I will give you actually some tips to help you to choose your next projects, like better project, right? So how many of you worked in like horrible projects? They really sucked. Okay, good, cool. That's almost everyone. That's pretty much it, right? And then it's actually our job to try to make it as good as possible. And then let's see how we can do that. So, nightmare, or kind of the opposite, would be kind of a paradise, right? For us developers sitting there, it's like, oh, this is an amazing project. This is just nice. I tried to identify some kind of typical things that will help us, like to group all those kind of things that I've seen in projects in main kind of categories. And then you'll see things like that. There will be the main things. There would be obviously some stuff with the code, like, I don't know, tools for the coding. There will be like architecture. There will be some third-party libraries and stuff like that. There are obviously some tools to make it work, so like build tools and all this kind of integration testing and so on tools. And well, the last one is documentation. Quite obvious things, right? Because like everybody, when we see that thing, we're just like, oh well, yeah, of course, this is a good project, how it looks like, and then we can actually try to see how we can actually make those of you, pretty much everyone who had hand up in the air a few seconds ago, how you can actually influence your project to make it nice and good and everything. Okay, so to do that, it had to be a little bit fun, right? So, and also, well, this kind of thing called procrastination. I ended up drawing two little helpers to kind of get you along this journey. So the first one, well, obviously we're talking about nightmares, so the scary one, right? This is a piece of art, seriously. And the nice one, the other one, are you ready for the other one? Ooh, the unicorns, right? That's actually quite a funny story. There was one place that could like print the T-shirts with your own stuff. So I went there and I was like, can you print this unicorn on a T-shirt? And they were like, yeah, sure, cool. Oh, this is so cute. Did your daughter draw with that? And I was like, yeah, that was her. Totally. The truth is, well, it was me. Well, anyway. Okay, so since we're talking about nightmares, I want to go kind of a little bit back and make us think how it was to do this development back then versus how it is now. Let's talk about 90s. This is kind of probably around, I don't know, a little bit less than 10 years before I started working on the system and development and everything. I started in kind of early 2000s. So for me, some of those things were still actually recognizable. Some of them were fortunately kind of gone. So 90s. Do you know what's that about? Waterfalls. 90s, the time of beautiful waterfalls. I mean, yeah, we did waterfalls. We didn't do agile and stuff, which was okay. That kind of sucked, but now we don't do that anymore, right? I mean, imagine sitting now, when I show you those things from 90s, just imagine yourself sitting with this kind of stuff now and how it's going to be. And, well, it kind of would have sucked to just work for a project for 2-3 years, come with something, and then people would be like, nah, that's not what we wanted. No agile, no kind of continuous whatever, and all those kind of things, right? 90s development, like code development, we actually used to write Java in Notepad and Emacs and Vim, and well, not even Java, I mean all kind of code, right? No help, no nothing, you just type your code, you save it, you compile it from a command line, and then that's it, right? Imagine doing that today. It kind of sucks, right? Another thing, doing the versioning stuff. I mean, now we have Git, Mercurial, whatever. I mean, those, probably most of you are using Git, which is really nice tool. It does branching, does all those kind of things. You can do distributed stuff. I mean, it's really nice, right? In 90s, we had Visual Source Save. It was bad stuff. I mean, I remember had to work with that early on, and that was kind of, anyone remembers that? Okay, sorry about that. Then we had CVS. It was kind of a little bit better, but not really. And then came like SVN, Git, Mercurial, Git, and all the other ones, right? So that kind of sucked as well. Now it's gone. Now it's nice. How did we compile and build stuff? I actually worked on a huge, enormous project, still doing this kind of stuff. We actually had bat files. We put the class path. We actually construct the class path in a bat file. It's like a huge thing of like spaghetti code with go-tos and stuff, because bat files would actually have go-tos, and there would be no methods, no nothing. There would be actually, imagine debugging that thing. Something breaks, you update something, and something suddenly doesn't work the way it used to, and then you have a bunch of parameters being sent around with go-tos and stuff. Good luck debugging that. It was really fun. Now you have just Maven and Ant. Actually, the fun fact is that Ant, that we kind of think was is super old and super outdated and everything, they actually came out first thing in 2000, in year 2000 actually. So in the 90s there was no even Ant. And yeah, well, we did also run Java from command line and build the whole thing. After we build up the class path, we would just put all that thing in. Imagine doing it now again. You don't really want to do that. Okay. Oh, this is my favorite. This is like the ultimate nightmare. This is the courtesy of my colleague. I asked him, I was like, I need something really scary. And he was like, he thought about that for a second, and he was like, yes, I got it. We did issue tracking in a really, 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 really weird way. And I was like, okay, fine. What is it? And he was like, well, we put all our issues in MS Access. And I was like, yeah, okay, yes, so? I mean, yeah, well, that sucks, but why so bad? And he was like, wait, I'm not done talking. You actually put the access, the database file, you would put in a shared folder. And then everybody would open their own MS Access clients or like programs that would use that file on a shared network thing. Can you imagine what can possibly go wrong, right? How many bugs would just like disappear? All that happened in the 90s, and now we don't have all that. It's fantastic. It's amazing. I mean, it's like we have super cool IDEs, we have cool build systems, we have really nice bug tracking systems, we have collaboration tools like wikis and, I don't know, all these kind of tools, right? But still, things like this happen, right? You're in a legacy code base, you try to run tests, you have no tests, you try to read specification, there is no specification, or well, what usually happens is like it's a bunch of Word files, totally outdated, somewhere on the same shared network drive still, and well, right? And then you try to write a fix. You're like, okay, fine, you know, I'll fix it. Then how hard can it be? And then you're getting eaten by a horrible, horrible, horrible hack, which someone did long time ago. Okay, so the moving parts. If we think about that, all those kind of things and all these kind of points there are actually something very, very similar, something we've seen before. This is kind of something continuous, continuous integration, continuous deployment, continuous delivery, all those kind of things do that. But sometimes, or most of the cases, those kind of things are being sold as unicorns, obviously, but they are also being sold as a kind of rocket ship that will take us to Mars, and to another planets, to another galaxies. And you should see, if you do all of those things, everything's going to be amazing. But the thing is that it's kind of hard to do all those things. It's hard to go from a like super old legacy system to being able to deliver 30 times a day. And just like this. It's a huge system, lots of code base, lots of legacy, lots of stuff, and it's hard. And then you don't have enough people backing you. Normally, there would be no people saying like, well, you know what, we think it's a really good idea, just stop doing new features for another year and do all that, and then everything's going to be awesome, right? But fear not. You can actually do those kind of things little by little, piece by piece. And you will still get to this kind of paradise thingy, right? So let's talk about things. Let's talk about development first, and let's talk about what I usually, when I come into this to a customer to look at their system, what kind of things I would normally start looking for and start digging around. And some of them are kind of quite major things, and some of them are not that major after all, but they still give me some kind of pointer of where to dig. I mean, where things might go bad. The first one is the code quality. The quality of those, well, beans or whatever that is a part of the system. So what is it with the code quality? What kind of things we might want to be interesting to first look at? So first thing I usually do is that I come in and say hello, and then I was like, do you guys have a code standard? And it's kind of obvious thing, right? We all know that we should probably have a code standard. Most of the cases, people would get nervous. They will, well, no, yes, no, yeah. No, we don't. And then you're like, okay. And sometimes they would say yes. Like, yeah, we do. And then you do, okay, cool. Do you actually follow the code standard? Then those that didn't get nervous for the first question, they usually get nervous. They're like, what do you mean? Do we know? Yeah. But the thing is, what happens is that when you don't have a code standard or when you don't follow your code standard, things will go bad at some point. And they will go bad in a way that your code will be not readable. It will be full of kind of weird things like bad formatting. That is the kind of the least dangerous thing, but you would have like commented out stuff, like, lots of weird kind of things, which you really don't want to do because, well, imagine yourself coming into a project like this that had no code standard, active code standard for quite some time. Everything is like, all the files are not readable. If you open it in an IDE that kind of tries to format it for you, and it formats in a totally different way, and then you commit, and instead of seeing just like 2 lines that's being changed, you have the whole file being changed, so you don't have diffs, you don't have anything. It kind of sucks, right? Just think about it. So, code standard. Another thing that actually might take your system down is as simple as encoding, right? Because we have, like, there's a bunch of words like this in Norwegian with this interesting, funny letters. And, well, those kind of letters you have in Spanish as well. And those are not the standard kind of ASCII stuff. And if, in the best case, those letters would become a square, little squares. In the worst case, they will take your system down, they will break it. I've seen systems break because of that. I've seen systems go totally down, like production systems go because, oh, well, we just encoded files a little bit wrong. And I was working on a project, I was reviewing a project that was around, I think, somewhere in between 350, 400,000 lines of code. And they had, I think, 5 or 6 different encodings in their files. But then the thing is that when you build system, you build with one encoding, and all those different 5, 6 encodings are kind of tried to be mapped by the build system into something different. Again, what can possibly go wrong, right? Well, actually, the truth is that it can, and it's quite a lot. Another thing that it is a little bit less dangerous, quite actually not so dangerous. But this thing actually tells me quite a bit about what happens in the project. If I have like a bunch of different MIME types, for example, Java files, I know that there is probably quite a big risk of all the developers using their own tools instead of kind of something centralized, which can be fine as long as it kind of people are aware of that. But most of the cases, when you have lots of MIME types for one specific kind of type of files, that would give you some kind of pointer to, okay, maybe I should look a bit closer into that, because they're probably using different developer tools. They don't have code standard. They don't kind of possibly talk to each other. They don't have any checks to kind of standardize everything. They probably don't do that much of the other stuff that is kind of not directly connected to that, but still in the same kind of idea, like, for example, static code analysis and all those kind of things. So this, actually, a harmless thing, gives you a little bit of like, aha, I probably should look into that. And again, the same project, 5 different encodings, and there were like 7 or 8 different MIME types. So Java files were everything from text file to HTML file to XML file to whatnot file. And it was, well, I mean, it kind of worked really well with the rest of the assumptions I kind of made. And then I saw actually at the end that it was like that. Another thing is that when it comes to code quality, quite obvious things actually, but still people usually don't give like a totally positive answer when I ask them. I was like, do you guys do code reviews? And again, the same project, they were like, yeah, nah, we don't do that. I was like, why? Well, we just know each other so well. We're a small team. We're 4 people. We're just managing this super legacy system with lots of lines of code, and we know each other so well. We've been working so much together, so we don't really need to do that. We trust each other. And I was like, but yeah, but this is not what is it about. This is about actually using the other person who you're doing the code review with as a rubber duck. You actually try to explain things to the person and saying like, hey, I did this and that because of this and that. And then it's like, oh, wait a second, I probably shouldn't have done that because, yeah, well, let me fix that. And those things happen. And those things happen to quite a few of us. You just start asking questions, start explaining it, you just realize that you did something wrong that seemed totally reasonable back then when you were writing that code. Okay. Let's talk about the development tools. So tools that help us to go by, tools that kind of we were missing back in the days. And like the first thing is something called versioning, right? We have really good tools to do that, but the also important thing is that it helps us to, well, one thing is that you can use it for a backup of your code in a way, right? But this is something that helps your code be nice and clean. You can put some checks and everything. You can also, another thing that's very closely connected to that is branching, which is actually quite an important thing. It's not just like you do feature branches and stuff like that and everything. I worked in a project like the public sector projects where prioritizations might change because of some kind of I don't know, laws that's being changed and being passed and not passed and so on, because of things happening in the government, elections, different things. So I actually had to work with something I kind of called political branching, because they would just come to you and say, hey, you know that feature? You wait with that. You don't do that. But it was supposed to be in a production next week. So we're doing testing, everything. Yeah, I know. But that's out. We have to wait for 3 months because of some law changes and stuff. And then if you don't have proper branching, if you don't have all that, you are in trouble, right? So branching is not only just kind of nice commodity kind of thing, it's also a way of handle changes. And imagine if you have like 3 or 4 running versions at the same time. You have one in production, you have one going you have one production branch, you have one development branch where all the new features are living. You have another version that you have to support because there is like some other reasons, and then you have like 3 or 4 different running versions in the same time. That might happen, and that was happening actually quite a few times. So important thing, right? Another thing which is kind of quite obvious, but still it's quite easy to see and quite look at when you look at the code is the complexity, testing, those kind of things. I mean, by complexity, I mean how readable is your code? How much time do you have to spend as a programmer, as a developer, reading that code? I've seen code with like, I think it was like 10 or something, like nested ifs with lots of if like if lots of things and, or, and, then there's another if inside it, and there's another one, and there's another one, and another one, with like 10 levels. It probably was a really good idea right then, but can you actually yourself, when you wrote that, 3 months later actually read that thing? Probably not. Probably you're like, how was that thing again? And you end up like setting breakpoints, going through all that and everything. Nightmare, right? Same things with testing. So you can actually, you can just do a lot of things. You can escape a lot of those nightmares without with having tests. So you just run tests and see if they fail or they pass, and it will give you some kind of ballpark of where you are, right? This is Sonar Cloud. This is a cloud version of Sonar Cube, of a static analysis tool. And this is kind of, I just went in there, they open it like, they have it open for open source projects. So you can, if you have an open source project, you can put your stuff there and they do static code analysis for you for free. And then you can just get some nice metrics and data about your stuff. So I chose Java files and started looking at all of those projects. So if you just ignore all those that have 0%, because they're probably doing some coverage, like test coverage and everything in some other way. I kind of hope so anyway. So ignore those, and ignore those really few that are on 100 or close to 100, so somewhere in between 90 and 100, because they're doing really well. But there is a huge amount of things right in the middle there. Quite a lot, actually, right? And some of them are actually quite big, right? So one of these things that was there, it was there for a couple of months ago at least, haven't checked how is it doing now, but I probably guess it didn't change that much, is actually PMD. It's one of the tools that I'm going to advise you to use in a little bit to check your code. Well, they have 185 bugs. Well, something identified as bugs by SonarCube. They have 180 vulnerabilities. They did something with code smell, so it kind of plummeted, which is really nice. And code depth and this kind of stuff. The coverage went up, which is also a nice thing, but still, the coverage, the test coverage is just around half, 62%. So, the point is, we all know that this is kind of cool stuff and good stuff to do, but even guys who are actually making tools to do that kind of stuff, they sometimes might not even do that. For different reasons. Sometimes you don't have time, sometimes it's auto-generated code, sometimes and everything, but then you should actually do something about that and add some ignores and everything, so Sonar is actually not taking that into consideration, right? Yeah, well, just examples of what it is, and some of those are, I mean, the bad things, the worst things there are the blockers and the critical bugs, and you see that we have quite a few of them. I mean, the major and minor and all the other ones, they're kind of, you can look at them, but a little bit later, but like the probably should be 0 of blockers and majors, and criticals, sorry. And well, there are quite a few of them. Some of them are kind of harmless, but still, right? Okay. Speaking of static analysis code, static code analysis. Sorry, it's a little bit early in the morning. These tools will get you what you saw in a previous slide, but they will also give you this kind of nice gamification thing. If you put up a screen in the place where all the you developers sit, all of us sitting there, we have a screen showing something like this. And there would be like green arrows pointing up, there will be red arrows pointing down, there will be like, you get this kind of little gamification things like, oh, shoot, coverage went down, let me write a couple of tests and it kind of goes up again, yay. Or, you know, and you do that gradually, because what I see is that when I ask people if they do static analysis code, they will, they will Some of them will say no. Some of them will say, yeah, we do it someday. We used to do that, but then we kind of stopped. And then there will be very few who would actually say that, yes, we have actually a screen that everyone can see and everyone can actually follow. And this is really, really, really nice thing to do. It's actually just like our human psychology kind of thing. It helps us to see the product of our work. It gives us some kind of this kind of instant reward of doing stuff. And it's, well, it's fun to see things kind of going well. And it's just like, oh, I did that. It's really nice. Yeah. So you can do a lot of checks. You can do checks of complexity. You can do a lot of checks on possible bugs in the code, all those kind of things. And there are actually plugins that will help you. You don't have to like submit all your code to a special build job that will do that and give you an answer 1 hour later. You can actually have plugins for your IDE that will kind of download the same rules. That's the important part. Download the same rules, because if you're validating on something different than what it will be validated on later, it's kind of useless, because you will still get some other errors that you will not see here, right? So you download the same kind of rules, and it will give you hints of like, hey, you know what? This might be an issue. Or you open a random Java file, you want to do a little bit of change, writing another method or whatever, and you see that there are some other possible bugs in the file. You just fix them at the same time, and then boom, right? Yeah, plugins. I kind of talked about that already a little bit. So some kind of things that help you to go through. This is kind of important developer tools. Let's talk about something else. Let's talk about some things that we usually tend to forget. Third-party libraries. We all use them. I mean, show me a project that doesn't use like a library that was made by someone else. You don't write everything from the bottom, from scratch, right? Okay, cool. But how many of you... Okay, let's do just since it's the morning, early in the morning. How many of you are using third-party libraries? Yeah, there you go. Cool. Everyone. Okay, how many of you know what actually libraries do you have? Okay, 1, 2, 3, 4, 5 hands. Okay, keep those up. How many of you know versions of those? Okay, cool. A little bit less, fewer hands, but still like in total there are three or four. Really good. I mean, those of you who still had your hands up, very, very, very good job. This is what most of us usually forget. And why is it so bad? Well, there are different issues with that. I mean, this is the obvious one, right? Do you actually know that Yoda time library or whatever, I don't know, anything, some kind of library that you're using doesn't have this kind of horrible vulnerability that will let you in to do crazy stuff, or somebody else to come into your system and do crazy stuff, right? This is kind of the obvious things. Do you know if it has bugs that kind of cause some kind of weird stuff? Another thing that we kind of think even less about is the licenses. And the licenses, I don't really care if you have to pay money or don't pay money. That's another story. That's fine. But what it actually forces you to do with your code? Because there are some licenses, kind of, here I wrote the code, use it, I'm cool, just reference me, happy days, right? But then there are some other licenses that are kind of viral that would, if you use it in your code, it forces your code to have the same library, same license. And that is might be a little bit problematic, because I was working on a huge project, and then I suddenly realized that one of the libraries, or one of the system components they were using, there was GPL. And I was like, are you GPL? And they were like, oh, no, God, no. Because we're like super critical project, we cannot do that. I mean, no, this is not good. And that's open source versus closed source kind of story. That's totally different story, so let's don't go there. I kind of don't really buy that argument anyway, but that's another story. The thing is, and I was like, okay, cool, but do you know that thing is GPL? And they were like, yeah. I was like, yeah, well, technically that can make everything GPL. And so somebody can actually call and say, hey, you know what? I want to code for that system. Because by making it open source, it doesn't mean that you have to put it on GitHub or something. You can actually, you should be able to provide the code upon request. And then, well, they weren't really ready for that kind of thing. Another thing they had for another, well, actually, there is a good ending for that story. They were using some kind of integration with web services and everything that made the rest not GPL, so everything was cool. But another thing they had, I found another third-party library, and then I was like to do some kind of document management kind of thing to talk to the document store and stuff like that, like the PDFs and stuff. It was the version and the library itself, it was, I found it at the end, after a little bit of Googling, I found it in Apache Attic. How many of you know what Apache Attic is? Apache Attic is like, it's, you know, the story of elephants when they kind of go old and they go and wander to some place to die, like kind of the graveyard of the elephants. Apache Attic is this graveyard for Apache projects. So anything that goes to die that nobody maintains, nobody touches, goes to Apache Attic. And I was like, hey guys, you know that, right? And they were like, okay, maybe we should upgrade. There was actually a parallel project, a fork that was totally finally, perfectly maintained, but it wasn't the one they were using. It was older version, it was not that fork, it was kind of, well, a little bit of explanation why it might be a good idea to do all these kind of things. There is another article to explain all this thing with licenses and everything that I came over a little more than a month ago, I think, which is pretty good. Another thing, again, obvious thing, third-party libraries are actually aware of they're maintained, updated, they're actually compatible with each other because they might be actually importing two different libraries so that import same library in the background again, but there are two different versions, and then you have a conflict, everything breaks, back to nightmares, right? Another thing is that the Google, this one is getting a little bit old. This is like year old now, but they do it from time to time. They run some tests on open source libraries, like well-known ones, the ones that people are using a lot and stuff. And then they kind of, there's a link, they found a bunch of vulnerabilities. I mean, well, this is how it is. We developers, well, sometimes, really, really rarely, very seldom, we write bugs, we create bugs, right? We don't do that normally, and nobody does that. But like, you know, sometimes, really, 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 really few times it happens, right? The thing is that all those bugs are being created, patched, updated, and new versions come out. So you actually have to keep up. Yes, maybe you don't want to do like update every single version, but you still have to have a strategy to do that, right? Another thing is like, how do you do your packaging deploy, packaging to deploy, packaging delivery deploy, all those kind of things. How do you do that? Do you do it manually? Do you do it automatically? Do you do it in the same way for all of your environments? Why is that important? Well, because it kind of tells me a bit about maturity of your project. It tells me about how often and how fast you will find bugs in your deployment routines. If you do some things that change and you do manual deploy all the way till you go to production or pre-production, well, you will not see all those errors in the script, deployment script, until you get there. That kind of sucks. But if you do it all the way from your development environment all the way to production, you will actually find them like this. Yeah, so you should deploy in the same way, in the same kind of manner for all of your environments. So whatever that is, you might have development, test, staging, whatever, right? Tools. I'm not going to tell you what to use. I'm just saying have a look at some tools. Find the ones that fit you. There are good tools, there are bad tools, there are ugly tools, but still good. And they'll help you. Just use them, right? Another thing to think about and to talk about is the architecture. And architecture is important because, like, you have one of the things, like, people will talk a lot about the architecture, like microservices versus monolith kind of thing. But I mean, it doesn't matter. The thing is, even if you have a monolith, you still should have like a package structure and everything inside your code, and make sure that your architecture supports continuous deploy and continuous delivery and everything. Because, I mean, are you actually able to deploy 16, 15, 30 versions of your system a day without downtime? Does your architecture support that, right? How is your application architecture looking? Do you have like packages inside your code, inside your big monolith or not? Because that will actually even make your life easier when you do builds, when you do like things with Maven or anything. If you just look at them and see the dependencies and try to build them in parallel instead of going one by one, that will cut down your time, build time, for quite well. We had this system of 450,000 lines of code with tests and everything. It would take around 20 minutes to build. 20 minutes on an SSD. You upgrade to Maven that supports parallel versions, like 3 point something, you cut down your time to like 12 minutes. This is almost half. Imagine, I mean, like around 50%. Big system, lots of code. That's actually quite fast. Obviously, integration architecture is the same thing. I mean, does the things you integrate with also support being down, or that your system is down and stuff like that, right? Code package structure, I talked about that already. Let's talk a little bit about tools. So tools, first of all, one of the main tools is your environments, your playground. This is where you build the sandcastles, and then you kind of cast that sandcastles into concrete and then go to production, right? Kind of. So environments, do you use the same routines for deploy? We talked a little bit about that already. We talked a little bit about why it's a good idea, and it is a good idea, right? Are the environments similar? I know this is kind of a little bit of wishful thinking, saying that my development environment should be as strong as production environment, but well, at least you can strive to do that. At least you can have at least the same setup and everything. There is a thing that we had in another project I was working on. We had a bug, like performance thing. If you do some this and this and this, everything would go slow, bottleneck, weird stuff, you know, all that kind of things. And then we're like, okay, cool. We have to look into that. We do profiling, we do lots of things. We find the error, we fix it, we go to the customer super happy, saying like, look, we fixed this thing. And they're super happy. Everybody is like cheering. They deploy that. Guess what? Nothing happens. Why? Well, because the test environment where we actually managed to reproduce that had a bottleneck in a totally different place because the memory was different. There was less memory, so the bottleneck appeared actually in another place. So we fixed the bug, but it wasn't the bug that was actually causing trouble in production. So environments, similar environments might be a good idea for as many as possible environments. Probably not all of them, but as many as possible, right? Re-buildable with a script. Can you actually take down everything, throw your servers out of the window, put in new blade servers, run a script, and everything runs? Can you do that? If you can't, can you start working toward that? Because in a cloud world, it's like obvious. Everybody is doing that, kind of, trying to do. But with the old systems, why don't we do that there? Why do we have to do like, oh, well, first we have to install the operating system, then we have to install the application server, then we have to do this copy for this config file, and then we have to edit it a little bit, and then we have to do that, and this, and then we might deploy, and then it will probably fail, but then you can do that. And this is how kind of many of the legacy systems being deployed for the first time to a new environment. This kind of sucks. Because when you have a script, you can create new environments like test environments and stuff like that, and just like this. You can just delete it, just recreate it, like nothing happened, right? Same physical hardware. Oh, this is fun. This is another bug that we actually encountered, was that we were doing a performance testing on the system, And the customer was like super serious about that, and we were super serious about that. And they were like, okay, we run like 3, 4, 5, 10 times, I don't know, load of the system that normally gets just to see how it looks. And we're hammering that system, not production, test environment, hammering that system with requests and going crazy about it. And then they call us and they were like, the production is down and it's your fault. And we're like, no, well, no, we didn't do anything. And then we kind of dig into that and everything. We realized what happened was that production and test environments were running on the kind of the same same hardware, going to the same disk storage. So if you hammer test and it gets loaded with requests, and then it sends all the requests to the disk. So disks get kind of busy. And then production is using the same disks. Can you guess what happens? Well, they were a little bit embarrassed about that later, but, well, so it wasn't our fault after all. Monitoring is another obvious thing. Do you actually monitor all of your environments? Again, the same kind of thing like doing deploy to all of your environments in the same way. You actually you're able to see bugs earlier. This is another cool article to have a look about how you actually build for failure kind of thing, and how also they were building a software for Apollo 16, or one of the Apollo missions, I think it was 16. It was really kind of nice read. A list of postmortems, just like analysis of downtime on outages on the main big systems around the world lately. And when you look at all those, there's a link there. If you look at those, there is a guy maintaining that, which is really cool. And if you look at that, you see all that kind of things that happen, and this is mostly human errors, mostly these things that can be avoided with all the things I mentioned, right? Tools. So you have development tools. You have your IDEs. You have things that you can integrate with all the other tools that will help you to do stuff, which is really nice. You can do checks at commits. We talked a little bit about that already, right? Your code versioning system can do a lot of checks and stop before your code ends up in a code base, which is really nice. You can do automated tests. You should do automated tests on all levels, and I mean all levels. Unit tests, integration, like end-to-end, functional tests, and all those kind of things. You should have a build tool. Whatever that is. I don't care whatever it is. Just use one. Use it properly. Use it well. You should use some kind of build system that will put all those things together. Maven, Gradle, similar. If you're not sure what to do, take a picture of that. They will probably confuse you even more, but yeah, that's cool. One last thing. I have a few minutes left, and I want to talk about documentation. And this is kind of the ironic thing, because this is exactly what happens in our development projects, right? We're like 2 minutes left, we're almost by the delivery. Oh, shit, we need to do some documentation stuff. And that's what happens, and this is what we do. We put our like Word files on somewhere, which is kind of weird thing. And we never update them later. This sucks. We should do something about that. To do something about that, we should have some kind of tools for collaboration. Instead of putting it on a shared network file, as a Word file, you might want to put it on a kind of wiki, Confluence, whatever. Doesn't matter what, just put it there. And it must be one thing and one thing only, because I talked to some customers and I was like, do you have collaboration tools? They were like, yeah, we do. I said, cool, which one? I was like, oh, well, actually we have 2. And I was like, oh, cool. Can you guess which one of those 2 gets updated? Quick guess? Okay, the right answer is neither. None of them get updated, right? And that sucks. Same thing with issue tracking. So this is not issue tracking, this is bug containment system, right? And you see on the side there, but you get the point. Same thing, 1. I talked to a customer and I was like, the same customer, and I was like, do you have an issue tracking system? They were like, yeah, we do. And I was like, which one? Can you guess the answer? They were like, oh, we have 2. And I was like, no, why? I was like, well, we have like customer has 1, developers has 1, and then there's another guy, 1 person, sitting and syncing them manually. Would you want to have that job? Just think about that. I complained about that to a colleague of mine, and she was like, Yeah, but I don't know what you're complaining about. I'm working on a project with 3 systems. And there is a still guy, or a person, I don't know, girl, guy, syncing those manually. Really nice, right? So, this is the end. Remember all those moving parts, and remember all those things that kind of make your project really nice again, and just try to do things gradually and improve it little by little, one code line at a time. And, well, hopefully it will be unicorns and everything. There is a few articles that I'll just put up there, so if you want to have a look, and there are some command line tools to help you do some things that I was talking about. There is a blog post on that I wrote, and there is another one that is a little bit of a text version of the same kind of talk as I'm doing today. And, well, yes, I really hope that by doing all that, just one little code line at a time, you will get there and you will see the fantastic, a little bit fat unicorns. This is me. This is contact information. If you have any questions, comments, or anything, email me, tweet, whatever, and you can probably come down and ask questions in a bit, because I don't think we have time for questions in the room. So, thank you very much. Thank you for coming.